So it's the next day. We had connected everything in here in the last video, which I have yet to edit and actually put up, but it'll all be in order. So we migrated our power that was going to the sub panel. We migrated it into the transfer switch and then looped everything around back through the wall to the sub panel on the other side of the shipping container here. So that's live, so we can't touch that anymore. So we're just gonna close this up actually real quick. That's active. That's all hooked up. So there was a previous attempt at filming, and I filled up the card on the camera, didn't realize it. So there was a whole lot of stuff. I'm gonna plow through all that and see what I've got to show from that, because there was some interesting things, especially with the troubleshooting on the engine that we're gonna get to in a minute here. But I did determine what that is, that terminal block there. That's just 10 volts DC, period, all day long. It doesn't turn off or on when the thing functions. Well, actually, you know what? We don't know that for sure because we actually didn't function test the transfer switch. Maybe that goes away when it throws to alternate. We have yet to find out. So more to come on that. All right, back to what we got going on here. This looks like hell, and I got to agree with you. But, we do what we can with what we got. So you may remember this terminal block thing that was laying on the floor inside the gen shed. Well, we're using that as a temporary connection. I was going to use the original lugs on there, but apparently when these aluminum thingies get corroded and you try to back them out with the Allen wrench, they strip themselves. So I had to run to Lowe's and get these splice blocks. So I got one down there on ground, got our neutral, 2 hots, sort of zip tied in there so nothing touches. They're all insulated from each other, so we should be good to go there. There's a little bit of an air gap between those and the muffler. This is all connected. So at this point, the transfer switch is actually controlling the engine and making it, well, attempting to turn it on. That much we know. Yesterday, during the other filming session, ran into a whole bunch of problems with the motor itself. We had crank no start. It kind of started on the first try, and it was like bleh, 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 bleh. And I was like, it must be a fuel delivery issue. So I, messed around with that. Shot ether straight into it. It didn't even fire on that. So I was like, that's odd, no spark. So after doing some more troubleshooting this morning, we took the cover off the front of the motor here, and there's the flywheel and all that. Yesterday I had this ground wire for the fuel solenoid on the regulator. I had that connected here because at first glance that looked like a ground point. I was wrong. So what that is, you'll notice that there was this insulated plastic connector there. That is actually the kill line for the coils, for the spark plugs. So each plug has its own independent coil, and when the flywheel comes around and hits the magnet, get over here, right there, that's the magnet on the flywheel. That magnet goes across the coil, creates an electrical field in the coil, which then goes up into the spark plug, and bang, bang she goes. So what this is the kill line, and what this is doing is this is grounding out the coil so that when the magnet flies by and creates the field, instead of the field going up the wire, the field goes to ground and dissipates, and then the engine shuts down. So a couple things going on here. You'll notice that we got some chafage on this wire. I didn't do that. That's the way I found it. And then the other thing I found, which was actually connected to it, just like this, was this section of wire here. That was also like either chafed right the hell out, or looks like maybe Mr. Mouse got in there and nommed on it. And then you'll see there's a little spade connector here. Maybe it's not going to cooperate. But there's a spade connector there, kind of like here. And this side was like barely attached to that spade connector, but you'll notice what's going on here is this, I don't know what the focal length of the camera is, so if I'm like making this look stupid, I apologize. So this was touching the block, long story short, Jesus. Effectively killing the motor, not allowing it to run. So this wire, all the insulation was, you know, rubbed off or chewed off. And the bare copper, you see how it's all corroded and oxidized and green? It's been that way for a long time. So I gotta imagine that this right here is probably why this whole unit got swapped out with a new one, and this ended up on Facebook. They had to have known. Anyway, so where we stand right now, we have our 20-pound propane tank. We have our bought at Lowe's grill regulator, gas grill regulator. And then you may remember, I don't know, do I have that fitting available here? Yeah, this guy. So at one point, this was the bane of my existence, finding out what fitting this was. In the last video, I went over how I bought several things at Lowe's and Runnings, and none of them fit, and I was like, yeah. So I took this thing off in preparation to go down to the big box and find something that would work. And then it dawned on me, I was like, wait a minute, this right here looks like 1/2-inch pipe thread. Turns out it was. So you can see here, I mean, there's a whole collection of fittings and whatnot in there. I went into the Save It bin and came up with this shit show right here. So these are some air compressor fittings and various adapters to basically get the gas from point A to point B, and then hopefully into this regulator. Over here we had this sled over there when we were working, but this is the original fuel hose that went from the carburetor down to the regulator. I just found another piece of, I think this is 5/8. What it says on there? I don't know. It's probably 5/8. 5/8 hose to, you know, connect this, because yesterday this ground wire was banjo tight going up to here. So I tried to just, you know, get this to relax and not be such a disaster. I'm going to turn the tank a little bit here to put some tension on there to keep this from flopping into the flywheel if it gets rocking and rolling. I took this off and looked in there. This is basically some sort of solenoid, I think. Either that or it's a pressure valve. But or like a pressure sensor. I'm more inclined to think it's a valve, though, because it does click. I feel a click when I hold on to this and then throw the power on switch. Another thing to note, in yesterday's troubleshooting, when I had this all apart trying to figure out why it wouldn't start, come to find out, there's this big monster button right here that says push to start engine. Now this was kind of a mental stumbling block for me, because over at my parents' house we installed a Generac automatic generator. That one, the multi-function switch here where you go from manual off auto, that one you just say manual and it goes on its own. That one's got a little bit more intelligence to it. This one I didn't realize you actually have to push the button. The other thing we realized with this thing is this circuit breaker, the main breaker here, the ground for the system ground actually goes through this breaker. On the bottom side of the breaker is a little plastic box that must have a pawl or something that engages up into the circuit breaker itself. And when the breaker trips to off, it drops the system ground. And by default, because there's no ground going to all the ignition circuitry, the engine shuts down. So that's pretty slick. Got to admit, I kind of admire that. But we're kind of locked into that breaker. So I had mentioned that I don't like this box. I'm going to mention that again. I don't like this box. especially where all these controls are located, because where I'm going to be putting it up high, I'm not going to climb up on a ladder to mess with this. So what I'm going to do is probably just make a new cover for this and then relocate all these guts down to another one, you know, down low. Because we got to maintain that breaker. This is our system fuse. Typically this is like a 15 amp bus fuse, slow blow. You know, you always got to make sure that that's good. Apparently I need my better hand here. Or do I just have this clocked wrong? There we go. Okay, now it's in there. So I think we're at a point right now where if we fire this thing up, it's actually gonna go. I think. So make sure some of these wires are bent out of the way there. They're not getting close to the, you know, they're not gonna rub through while we're running, but they could melt through. Really, they could melt faster than they would rub. You know what I mean. Another thing I'm kind of annoyed with here. So that's the end of the alternator, and this is where the rotating bits are. There's no guard on this. And there's no guard here where the fan is, on the front of the alternator. And there happened to be no guard on the bezel cover. There was, however, this weird plastic rubbery air deflector thing that went out the side of the sheet metal enclosure. So, I mean, this was in a metal enclosure that sat on the ground. Excuse me. But there's not a single, like, screen or guard on the whole damn thing. So it's like, if this is on the side of somebody's house and you're like weed whacking or lawn mowing, you're blowing like grass clippings up against the enclosure, I mean, eventually that shit's gonna get sucked in there, and I don't know what they're thinking. So I think our next test here is yeah, look at all these cobwebs and shit in there. Yuck. I'm gonna get some kind of guard to put on there, because that's just how I want it. You know what? Yeah, these are tapped. I can see threads in there. So I don't know if I'll be able to go on like eBay and find like a used, you know, OEM shroud, shield, filter, whatever. The thing. I'll find the thing on eBay. For all of this, because I don't want crap getting in there. That's how mice get into places and wreak havoc. You know, where'd that little thing go? You know, right here. I'm pretty sure a mouse did that. Because, you know, they use soybean oil in the jacketing on the wires, and it literally attracts critters. You wouldn't do that to create, you know, follow-on revenue for repair, you know, billable repair now, would you? Nah. Yeah, try doing that on something critical like a hospital or a nuclear power plant. All right, so enough of me yammering. Let's see if this thing will go. So I don't know if I want to start it manual, or if we want to go up in there and hit the test button and actually do a switch over. I'm kind of, I don't know, maybe actually doing it manual here will also trigger a switch over, so maybe we ought to just go for the gold and, you know, just do it right from the transfer switch. So let's get you back in here. I'm going to get on my ear protection. Now I did have eye protect. There it is. Because, you know, once things get going, I don't want to, you know, end up in the ER. So we're going to set this to, actually we're going to turn on our main breaker. Set that to auto. We got battery voltage. We got happy gas. Let me see if I can kind of position you a little better here. So there's that. And then if we fire up and it goes and we get a transfer, I'll probably just kind of aim you at the transfer switch. I mean, there's not a whole lot to see. Actually, there kind of is. Hang on. When it transfers, you see that P? That's for primary. When it actually throws, there will be an A there for alternate. It's just printed on the other side of the thinger. Okay, so hopefully there's no fireworks and nobody dies. Here we go. Huh. I think it's going to try again. And it's going to try a third time and give up. Okay. All right. So what I suspect is going on here is it's not making electricity. So the transfer switch expects to see electricity within a certain time frame coming out of the alternator. Otherwise, it's going to shut down and try again. A common issue with old generators and generators that have a lot of hours on them is the excitation current disappears or is too low to actually excite the field of the generator itself. So let me bring you in closer here. So these are the rotating bits. There's no fuel or anything, so you'll see that as I spin the fan on the front of the alternator by hand, the stator in the rotator, or I think the stator is the stationary part and the rotator is the rotating part. That kind of makes sense, right? So, and these are copper windings, copper wires. As they sit right there and they rotate, they're just rotating material. There's nothing happening. There's no magnetic field, there's no electrical field present to actually oppose each other, because that's what that's how you actually make the electricity. Is the engine is just providing rotational force. But without a spark, without, let there be light, so to speak, there's nothing happening. There's no energy being created from one thing rotating past another. However, if you excite the field, in other words, if you introduce a little bit of voltage from another source across the field, now you kind of create this exponential chain reaction, and the pixies start fighting each other, and now you get electricity coming out of the alternator. And like I said, it's sort of a chain reaction, so you have to moderate it, and you kind of have to, put in voltage, take away voltage, and kind of regulate that process in order to keep your output consistent. Engine RPM also has a little bit to do with it as well. But probably what's happening here is we don't have any excitation current going into the alternator. The way this one produces its current, and there are two capacitors in there, two big massive capacitors. It's a very simple and cheap way to create excitation current. So maybe those capacitors are drained down, or maybe they're faulty. So we're going to have to test that. First, we're going to throw our meter right here on these bad boys and verify whether or not we're seeing voltage coming out of that thing. That's the first test we're going to do. Then we're probably going to have to bust out the owner's manual, which I have. I'll give the guy credit that I bought this thing from. They had all the documentation for it. Then we're going to have to figure out the winding circuitry diagram, and particularly the capacitors and the excitation field, and see what the deal is. I'm just going to say this straight out. I'm not an electrical engineer. I'm not an electrician. You know, this is like a hobby for me. I'm a network engineer. Capacitors scare the hell out of me because, you know, they charge up and they have like kill you dead voltage inside of them. So you got to be super careful with them. And the ones that are in there are big, you know, big, thick, round ones. And, you know, you just know that they're like, hey, I'm going to mess you up. So we're just going to take our time with this at this point, you know, once we get in there. Backup plan. So the diesel generator in there doesn't have that capacitor nonsense because it's like a, you know, real industrial grade generator. It's actually got an AVR, which is a circuit board it's an automatic voltage regulator. And it's a circuit board with, you know, stuff built into it, you know, intelligence, that it does the voltage regulation on its own. So it functions in the same way as the capacitor, but it's a lot more precise. And that's kind of what, you know, you need when you've got electronic devices hanging off your generator. You want your voltage tolerance to be very close to a set point so that you are feeding, you know, like computers and servers and, you know, electronic devices very clean, consistent power. That's, you know, that's what they thrive on. So that big diesel in there's got the AVR. I have spares for that. I've got 2 spares, you know, because you're supposed to. You should have redundancy for, you know, critical things. So in the event that we determine that either these capacitors are tits up or there's just something wrong, we may end up just swapping out the capacitors for an AVR. And probably that's going to happen when we redo that whole case. Because then when I gut this case and move all the other stuff out to a remote box, there's going to be a lot of empty space in there. And then that's where we're going to dump our AVR. And that'll be the only thing that's in there. Similar to what's going on with the diesel. At some point, we'll probably pop the cover on that. And you'll get to see that. Because it's going to need a PM, you know, preventative maintenance at some point. Just go and make sure all the bolts and terminals are tight and everything. That's another thing that, you know, often gets neglected in most places. So, enough yammering. Let's throw our meter on here after we do another test and see what we get. Alright, so here's the fluky, the Kleiny Klein. And it defaults to AC. I'll probably, leave that there in the propane tank so that, okay, now I gotta figure out, like, actually how to attach this and, like, where, because, that ain't gonna work. Can I go on the side of, yeah, that'll work. I get it to stay. The other thing is it's probably going to vibrate as soon as it fires up and fall right off. Stay, damn it. All right, so get our PPE back on here. All right, we're gonna go for another automatic test and see what we get. Hey, do something. Oh, you bastard. It's trying. I can hear the relay clicking in there. Okay, what happened? Main breaker's on. That's in auto. Okay, so it's doing this thing again where it won't start. So, did this yesterday while we were troubleshooting. And basically what's going on here is the solenoid on the starter motor is cranky. It's cranky, therefore it don't want to crank. So the way we fix that is by gently encouraging it. Something in there is wonky and it just don't want to go. Probably a good candidate to replace, because we don't want our automatic starting hopes and dreams to be let down by that piece of junk solenoid. And I heard so it appears that it is making voltage, but it's only making 170 volts when it's supposed to be making 240. So the transfer switch probably sees that and says, you know what, there's a problem here, let's try again. And obviously it tries 3 times and then it gives up. So maybe one of those capacitors is bad and the other's not, or maybe they just need to kind of have multiple attempts before they reactivate, maybe? I don't know. Like I said, I'm not an electrical engineer. What the hell do I know? Let's move one of these probes. I need to put this wrench down. Let's move one of these. See, I always assume this stuff is live, so I try not to touch any of it. Let's try again from neutral to the hot and see what we get. Oh, that's why I was holding the wrench. Okay, it was doing that yesterday too, and I thought I had fixed that. That was the starter. So, it's doing the exact thing it was doing yesterday, and I thought I had fixed that by isolating that wire that I thought was killing it. This guy. But apparently not. So I wonder what the deal is here. you know what could be the deal? Let's verify what our voltage is in the battery. Because maybe the battery itself is getting too low, and there may not be enough voltage present to do all the things. We're at 9.5 volts. Actually, no, we seem to be taking some charging current, probably from the transfer switch itself. But I'm wondering if we should bring a battery booster over here to keep this thing up. Okay. So we got some more electricity going into that battery. The theory is maybe there's not enough voltage present to hold all the solenoids open and give it the right amount of fuel. Either that, or we're not able to flow enough fuel out of our grill regulator here. And this grill regulator is not adjustable, which sucks. So we can only flow what we can flow. And if the engine needs more, then we're kind of SOL. I don't really have any other connection that I know of. So, let's see if it'll go again. Actually, I wanted to get this meter set up. So we're going to measure between neutral and a hot, and I'm going to measure both hots to see if the reason we're not getting 240 is because one of the phases is lower than the other. All right. Alright, so I tried to feed it a little ether there, which was a little touch and go, because if it had backfired when I was feeding it, we could have had a big fireball, but whatever. Yeah, so I don't know what the deal is here. I wonder... I don't know. I wonder if I were to try mainlining this fitting right to there with a different type of adapter, if it would flow more. Maybe this quick coupler that I've got in there is restricting the flow of gas. I don't know. It's worth a shot. So let me pause the recording here while I suppose I could edit it and just speed it up. That way you're not spending all day looking at silliness. We're going to set that to off so that we don't get any surprises. I need a wrench. throw that over here. The other thing I'm curious about. Alright, so I looked down inside that valve there, in here, and you can definitely see the plunger going back and forth. So this valve appears to be functional and functioning correctly. This, I don't know what the hell's going on in here. I mean, it clearly it's getting gas. I don't know if it's getting enough gas. So that's what we're going to do here. We're going to try and swap some of these fittings real quick and see if, you know, the restriction in this nonsense I got here is what's causing our problem. Let go. Alright, now hopefully, and shit, that ain't the right kind of connector. Yeah, I need a flare connector. Damn it. And then that. Do I have two of these? Hang on. Yeah, so what a disaster. Alright, where the hell all my wrenches go? Alright. We don't want that tape going in there. Pretty sure, yeah, there's no way to increase the flow. And the part that's really annoying is I know that somewhere I have a regulator that you can adjust. I just don't know where the hell it is. So we get our thread tape on there, a couple wraps of that. That goes in there like that. Then so when you're doing thread tape, you have to account for the way you wrap it. Because if you wrap it wrong and go against the rotation of righty-tighty, lefty-loosey, you want the tail end of your thread tape pointing to the left when you're tightening. Because if you have it pointing the opposite direction, let's say like that, and you were turning like this, let's say that we were going that, the start of the thread was on this side, you're hitting into the front edge of the tape, and you see how it starts to bunch up? That ruins your seal. So you always have the end of your tape the opposite direction of what you're threading into. Same with this direction here. So, and you can see here, we're all going righty-tighty this way, but this way, as far as these guys are concerned here, this is, that would be lefty-loosey. So we need to tighten everything here first, then tape this side, then screw that together, then put it in the regulator, and then attach our flare connector so that, we're not inadvertently loosening up or, ruining the seal on some of these other things. Just drop everything often, especially on like a hard concrete floor, so that you ruin the threads and then you can't screw it together anymore. Don't actually do that. I'm just kidding. Apparently today I'm just having a case of the dropsies for some reason. I don't know if I had too much coffee or what. So we need to tighten these guys right here in our hand to get this joint good and tight. And I mean not like hand tight, I mean like, with the wrench. Because once we screw this into the regulator, if we try to wrench here on the rest of the assembly, remember it's going to undo these fittings. Good enough there. And again, this is just a wag, as we say in the IT world, a wild ass guess to try and eliminate that restriction in those fittings to maybe flow more gas, but I doubt that's the problem. I think there's something else going on here with the motor. But I mean, it could be fuel delivery. I thought it was fuel delivery yesterday. It kind of feels like fuel delivery. So I think this time when we crank, when it starts to catch, we're going to feed it some ether and see if we can supplement its food source and help it out. So I'm just going to get this in there a couple turns just to make a good seal, and then point our fitting toward the propane tank. Starting to get tight. Yeah. All right. Because if I get it tight enough, or tight to the point where I can't physically hold on to it, and I gotta engage, use the other wrench, that'll just be annoying. Okay. I kind of like the QD attachment because it just made more sense to be able to quick disconnect and unhook everything and make it safe. I can still do that at the tank. It's just you got to turn more knobs. All right, let's see what we get this time. We're gonna set that back to auto. Breakers on. Give that a tappy tap. gas is on. I'll hold this in my hand so it doesn't fall on the floor. Oh, and then the solenoid's gonna give us grief again. Yeah, that thing is loud. Good thing I was wearing these. Are we still recording? Yeah, okay. So apparently fuel delivery was the issue, as you can see. All those fittings that I had were restricting the flow of gas to the point where it wasn't running enough. So now the issue is, are we going to see a transfer or not? I kind of assumed that it was going to transfer on its own and go to alternate. I'm going to try pushing the button on the thing one more time to see if it'll actually throw it that way. Maybe I'll try actually killing the power to the barn and actually simulate an outage. Maybe it'll go then. Or I could read the manual. But what's the fun in that? Okay, so apparently when you hit the button again, it shuts it down. All right, whatever. But at least we know that this thing functions, and it's functioning correctly. It's making voltage. We saw it making proper voltage here. We saw proper voltage here. So now I'm curious as to why it didn't actually do a transfer. Unless push to test is just an exercise. You know, it's just a like a function test of the motor and the alternator itself. I'm trying to think when the Generac over at my parents' house does its test. Well, I mean, exerciser test. I mean, it doesn't actually initiate a transfer. It just runs. So I don't know, these ASCO guys, you know, the automatic switch company, I don't know what their definition of test is. Maybe it's just an engine run test. But I mean, I'm interested in, will the whole thing transfer and transfer properly? So I think what we got to do here is simulate an outage. So we're all good to go here. We're set to auto. We know the thing functions, except for that freaking starter solenoid that sometimes doesn't like to cooperate. So you know what? Before I get annoyed, where'd that wrench go? Let's give it a preemptive bit of encouragement, shall we? All right, so let's go over here and simulate an outage. Boom. Come on. Did I get rambling and like turn that off? I don't think so. Oh. Yeah, I was gonna come in here and be like, let's see if these guys are happy or not, but she gave up the ghost. Oh. Well, I mean, the transfer switch worked. Outside lights on, so we're good there. UPSs should be happy again. And we just heard that go click in the opposite direction and go back to utility. So now the UPSs should be happy. Happy, happy, joy, joy. All right, so we're getting there. We're getting there. I still think we have a fuel delivery issue. So this setup here, although it sort of functions, it is not enough flow. So in other words, we're not flowing enough gas out of this bottle into here and up and around in order to properly handle all the load. There's Home Assistant bitching about the power outage. Okay. So we know now that the transfer switch functions, that the brain box is in fact good to go. That actually produces electricity, and we probably need to figure out this janky ass gas delivery, and then we'll be good. And I don't know if you caught that, but when it was running earlier and you heard a change in tone, that's when the UPS is actually picked up on the utility power and started sucking energy out of that thing. So I think it was good until, we used up all the fuel in that 5/8 rubber hose, and then this thing, again, could not flow enough to supply that. And I mean, I'm not surprised. I mean, where the hell is that fitting? That fitting I keep liking to show you. At any rate, you know how big around that was. That was like 5/8 diameter, 5/8 diameter bore. I mean, this is probably 1/4 inch bore here. So it can't supply enough fuel. So I think that's what our problem is now. But yeah, so far so good. We've almost got a functional system here. So I think at this point, I got to see if I can find another propane setup locally, maybe on like Facebook Marketplace, or I've exhausted Lowe's and Runnings. They don't have that stuff. I mean, the only propane stuff they really carry is for like gas grills and that kind of stuff. They don't carry anything heavy duty, for like generators or high demand appliances. So without really creating something crazy here that is borderline unsafe, I think I'm kind of at a holding point for now. But it worked. It actually worked. So I don't know if this line here that was in there was the actual cause of our problem, because the way you saw it backfiring there just a couple seconds ago or minutes ago, that's what it was doing last night, and that's what led me to think I had a fuel delivery problem and tore this whole thing apart. But then we found this wire as a side effect of that adventure, going down that rabbit hole. So this probably had to be fixed eventually anyway, because this probably would have vibrated at the wrong time and caused an abnormal shutdown. So I guess it's good that we tore into it, even though that wasn't the root cause. But we found a landmine that could have been stepped on later. Yeah, so I'm pretty satisfied right now. Once I get this fuel delivery figured out, then what we're going to do is some more serious load testing. And I'm waiting on parts to arrive for the kill line for the relays that are going to shut off the air compressor and the water heater, up above. So I ordered a 200-foot extension cord. I ordered a bunch of DIN rail terminal blocks of different colors so that we can designate what's what as it travels around throughout these various areas. And I've got the relays and such ready to go for the most part. So now it's just a case of putting that all together and figuring out the actual logic and how I want it to behave. I'm still on the fence. So the relays that I have in hand right now are 12-volt coil, but I'm on the fence as to whether I want to use 12-volt or if I want to change those relays into like a 120-volt coil. So if I go with a 12-volt coil, then I need to get 12 volts from somewhere. Now I do have 12 volts coming in here from the generator itself, via the battery line. So I do have a source of 12 volts, but the issue that I'm concerned about here is these wires are like 18 or 16. I think they're 18 gauge wires. Yeah, they're 18 gauge. 14 gauge or 12 gauge is good for 20 amps. Let's start at the top of your typical household stuff. 10 gauge is good for 30 amps. 12 gauge is good for 20 amps. 14 gauge is good for 15. 16 is good for probably 10, and 18 probably even less than that, like 7.5 or 8 or something. So we got to be super careful of how much amperage we're pulling out of the battery for the generator, across those little wires. Now, granted, a small relay is not going to be a whole lot of draw, but yeah, I'm not sure. I gotta, you know, look into this stuff in detail and figure it out. I mean, it'll be a whiteboard session when we get to that point. You're really digging into the logical and the physical layout of this kill circuit. So when we get to that point, don't worry, we'll go the full depth and breadth of what we got to do it right. What is that? Oh, that's the climb meter bitching. Yeah, so there you have it. This thing actually functioned correctly. The UPSs took power for whatever length of time that thing was able to output. And that's that. Let's do one more test just to make sure that, you know, something didn't go kablooey. Turn our gas back on here and come over. Actually, we're still in auto. Come over here and give it some nutritional supplement. Yeah. And then hit that once to reset because it was in a fault state. Hit it again to initiate the test. And our starter solenoid done, refused to operate. Come on, bud. Do it. It's sort of running. It's not getting enough fuel. I'm going to assume it's still good to go. It's just the fuel situation. You know what else it could be? Remember that whole voltage thing I was theorizing about earlier? Where solenoids weren't fully opening? Oh, the timer ran out on that. Fudge muffin. Let's try again. I'm going to give it another shot to redeem itself. Ah. All right, it still works. Spark plugs work. It's still, you know, it's still an engine. It identifies as a functional piece of machinery still. So we're good. We're good at this point, I think, to call it a day, at least on this video. I don't know if, you know, I'm gonna kind of get into anything else today because I still have to edit yesterday's footage into something that's like somewhat coherent. Yeah, I'm satisfied. I hope you are on this little adventure here. So we'll upgrade our fuel system and go from there. It's getting kind of windy. We're supposed to get this monster tornado maker. Well, we're not going to get tomatoes. We're not going to get tornadoes up here in upstate New York, but we're supposed to get a lot of wind and rain. But you know, our thoughts and prayers go out to everybody down south who's getting annihilated by all those big storms down there today, Saturday, March, whatever the hell it is. That's probably the gate opening. Come on, phone. Yeah, so maybe the during the power outage the gate reset, and maybe that's the sprout opening it or closing it. I don't know. We'll figure it out here shortly. We'll see what we got going on. Hopefully it's just the sprout. All right, sounds like a good stopping point. I will catch you guys later. Have a good one. Enjoy your weekend.